Hi everybody, I wanted to take a moment to follow up on finding a quadratic formula given a graph. So here I have two graphs, F and G, and I'll start with F. I recommend starting when you're given a picture like this by writing the factored form. So I know that I have a 0 of -4 and a 0 of 9. Remember, we can call those x-intercepts. So we know that f of x is equal to some a value, unknown a, which we're going to find, times the quantity x plus 4 times the quantity x minus 9. Now we use the other ordered pair, which in this case is 0, 3, substitute those x and y values, input and output, to solve for a. So y is 3, a is unknown, and x is 0. And so I've got 4, 0 plus 4, 0 minus 9, so 4 times -9 times a is equal to 3. 3 then is equal to -36a. Divide both sides by -36. And a is equal to -1/12. Now we can put all that together and we have our formula. So f of x, or y, is equal to -1/12 times the quantity x plus 4 times the quantity x minus 9. That is in its factored form, recall. You could certainly rewrite that in its standard form by foiling and then distributing your -1/12. Next example, we want to find g of x. And g of x bounces off of the x-axis. It only has one x-intercept, or 1, 0, at x equals 5. It's upward facing. It also goes through the ordered pairs 0, 3. And so if I was going to start by writing g of x in its factored form, I'd say g of x is equal to a times the quantity x minus 5 quantity squared. We talked about this in class today. Another way to write that would be, instead of x minus 5 quantity squared, you could write the quantity x minus 5 times the quantity x minus 5 times a. Same idea. Now, I know that when my input x is 0, my output is 3. That's this ordered pair. So I'll put 3 in for my output, y, a, -5 squared. 3 is equal to 25a. I'll divide both sides by 25, and I get a is 3/25 as an exact value. And so g of x is equal to 3/25 times the quantity x minus 5 quantity squared. We do have to square that. We say it's a second order or a second degree, that 0 there, and that's what causes the bounce off of the x-axis. It bounces as opposed to crossing like we had in f of x. Okay, a couple of other examples that people asked about, and I just ran out of time today, didn't get to talk about them in class. I want to solve for t. I want to know what values of t would make this statement true. Now you may be tempted to multiply by 100 and divide by t, but the problem there is you actually eliminate one of your zeros. So if you multiplied by 100 and divided by t, then you would end up with t squared is equal to 100. And there's only two values that make that statement true. If t squared is equal to 100, then you get t is equal to plus or minus 10. But the issue is that you're going to see in a moment, there's actually 3 solutions. And we can find that third solution by, instead of dividing by t, which again eliminates, if you divide by t, it eliminates one of your t values, subtract t and factor. So let me show you what I mean by that. 1/100 times t cubed, take away t, is equal to 0. And you'll notice that in a lot of the factoring problems, we set one side of the equation equal to 0. Because that helps us, we can factor, and once we know the factors, we can solve for the zeros. So now, the greatest common factor, which we ask about in it's the first question we ask in any factoring problem, is there a greatest common factor other than 1? If so, pull it out, is t. So t times the quantity, t squared over 100, minus t, or minus 1, I'm sorry, we factored out a t, so minus 1 is equal to 0. Now, you'll see that either t is equal to 0. As we've talked about in class, this is like alpha times beta equals 0. It is non-negotiable. Either alpha's got to equal 0 or beta's got to equal 0 to make this statement true. So either t equals 0, there's one of our solutions, or t squared over 100 minus 1 equals 0. Now, if I want to solve for t in this instance, I'll add 1, multiply by 100. That would put me here. T squared is equal to 100. And that's the same place we were over here. We know that the two solutions there are t equals plus or minus 10. But notice by subtracting t from the start, that opened us up to find t is equal to 0, whereas before we didn't know that there was a third solution. So you've got 1, and then positive 10 and negative 10, 3 solutions to that. Next example, 81 is equal to 1 over L squared. Now, in this case, notice we are not at risk of eliminating one of our solutions, because the reason we eliminated one over here is because when I divided by t, I got rid of one of my solutions. I'm not at risk of doing that here, so I'm going to, because there's no L connected to this term, so I'm going to say 81 is equal to positive 1 over L squared. I can take the reciprocal of each side, 81 over 1, so L squared is equal to 1 over 81. Take this, so the question is, what values of L squared would give us 1 over 81? And the answer is L is equal to plus or minus 1 over 9. So think about that for a moment. You take a fraction, you square that fraction, as we've discussed. If you square that fraction, then you square the numerator. 1 squared is 1. You square the denominator. 9 squared is 81. We get 1 over 81. So both of these, if we put them in, make the statement true. Positive 1 over 9 squared gives us 1 over 81, and negative 1 over 9 squared gives us 1 over 81. Last but not least, we've got 1 over the cubed root of x is equal to negative 7. Again, you're not at risk of eliminating a variable by you're not at risk of eliminating a solution by dividing as we were over here. So I'm going to multiply both sides by, or you could reciprocate as we did in the previous example, same thing, multiply by cubed root of x, divide both sides by negative 7, and we get negative 1 over 7 is equal to the cubed root of x. And the inverse operation here, instead of taking the cube root, we would cube both sides, and so x is equal to whatever negative 1 cubed over 7 cubed is. Now, negative 1 times negative 1 times negative 1 results in a negative 1. 7 times 7 times 7 is 243. And so we only have one solution here. We went from 3 solutions to 2 solutions down to 1 solution. That's all I've got.